All right, you welcome back to this section. So still on vectors 1, but in this section we'll be looking at position vectors. Yes, position vectors. We want to check what position vectors um, are all about. Okay, the position of a point A relative to a point of reference can be specified by a vector. If the reference point is the origin, the vector OA denotes the position of A relative to O, and it is called the position vector of A relative to O. We represent vector OA by A, then the vector A is the position vector of A. By that, I'm going to be showing you how we are going to go about making that or showing that with a triangle. Okay, so now let's take the positions. So this is the origin. Take that again. That's point O. That's point O. So this is point A, and this is point B. Right? Good. So let's have the uh, direction of the vectors of the line vectors. So this is OA now. So let's make a direction OA as the name reads, OA. So that means from O to A. So that means the arrow must be facing up. Then the same with OB, the two vectors we are talking about. So OB meaning from O to B. So it must be in this direction, OB. Right? Good. Then, and this is what? AB. So let's look at this in this direction. Good. So now, OA is a line vector. The position vector of OA can be denoted as A. Are you there? Good. The position vector of what? A can be denoted as what? OA rather can be denoted as A. So I can write this as vector A. So this is the position vector. Position vector of a line vector. Do you understand? Good. The same thing can be said for B, OB. OB also has a position vector of what? B, because it is relating or relative to the origin O. What I want you to understand is that both vectors OA and OB, which are line vectors, originates from O. So because they originate from O, we can say that the two vectors have their position vectors to be A, that's A, and B respectively. Do you understand? Good. They have their position vector to be A, that's A, and what? B respectively. So that's what we meant by position vectors. So now, a quick one. From triangle law of vector addition, recall that OA plus AB, remember, order of magnitude and direction, is equals to OB. Yes. Remember, I took the direction. OA follows AB. OB is counter moving against or counter reacting towards AB. So I can't say OA plus AB. No, it won't work. it is OA plus AB vectorially. It must, whenever we are writing vectors, it must be vectorially correct. Do you understand? We must take the direction into consideration. Direction of the line vectors, it must be taken into consideration. So that's what I've written. So by that, what triangle law of vector addition state. So from here now, I can say that this AB equals to OB minus OA. So that's what AB equals to what? B, that's the position vector of OB minus the position vector of what? OA. And that gives us the position vector of AB. Yeah. Do you understand? So that means this line vector AB has the position vector of what? B minus A. Because, so also, I can have it that if we have PQ, for example, what the position vector of PQ, vector PQ, that will be Q minus P. That's position vector Q minus P in that sense, relative to O, because this is PQ will give us OQ minus OP, and that gives us this position vector. All right, we have come to the end of this class. You can always subscribe to our channel, Clever Minds, to always get more topics in mathematics. Thank you very much.